here today. I'd like to thank the organizers and coordinators, for you and Xiaojin, and the volunteers who made personal effort to make this possible. Now, today I'm going to speak about ecosystem management. What this means, ecosystem is a forest, grassland, lakes, streams, and all of this has been under very strong pressure of human activities. And also, human society has a big received a big influence from ecosystem change. So we have to understand the interaction between them. Today, I'm focusing on 2 topics, although my abstract has many things. Now, the lake story. You might think these are, it's a clean lake. It's called Lake Kasmigawura, but in fact, water includes too much nutrients like phosphorus or nitrogen, and it's called eutrophic. Okay, sometimes they smell bad. So to improve the water quality, we need to reduce the amount of nutrients in the water. And the method to achieve this one all includes cooperation of many people, asking local inhabitants to use more efficient sewage disposal. But to collect this sewage disposal, they have to pay cost. Or asking local farmers to use a little more laborious method that will prevent the release of the fertilizer into lake water. Okay? By doing this, lake water becomes cleaner, everyone happy, but these farmers has to pay additional labor. So all of them include element of asking cooperation. So you recognize that it's really sort of public goods kind of situations. See? Suppose there are a number of players who choose between 2 options. One is economic option, cheaper, but as a result, more phosphorus will be released into lake water, make it polluted, or but it's cheaper. But cooperative or environmental benign options are reducing phosphorus release, smaller, but economic cost is higher. So if people takes all the time to the option which achieve the maximum benefit or minimum cost, economic cost, then there's no hope of that improving environmental, lake water. And you know that many people mention it, and public goods get these years, social scientists even are interested in doing experiments. They find out people do not always choose the option which maximize economic benefit, minimizing cost. Yesterday, Christoph Howell explained this in detail, and he emphasized that if you repeat this public goods game, then the contribution becomes smaller and smaller. Okay, that's very important aspect. But the fact that it is a positive contribution is very, it's striking. We have to explain this. If you think about these situations, and each player is anonymous. What he has done is never disclosed. Then, and no one should contribute to this one. Contribute and double and share. But if you do this experiment, many people contribute. That's very striking to me. Important is people are conditional cooperators. If many other people contribute a lot, then people are more willing to contribute. Okay? Now, if no one else contributes, people are less willing to do it. Now, I think that there is an emotional basis underlying these decisions. Not only economic cost and benefit, but also their willingness to improve the environment, or if someone doing just taking selfish options, they get hungry and punished. So, in thinking about lake water problems, we probably should take this into account and what happens. To see what happens in the next talk. Now, instead of thinking about just the people taking the option which minimizes economic cost, we will think about economic cost plus social pressure should be minimized. And social pressure is sort of people's willingness of sort of emotional basis, people's willingness of contributing to the improvement of the environment. And this is not just constant, but has two kinds of frequency dependence. Okay? The first one is if this issue of the water pollution, is a problem in local community, like always appearing on TV or newspapers, people always talking about water smells bad and we should improve this one, then each player, each person is more willing to contribute. Okay? The second thing is if all the others contributing, it's very difficult for you to not doing this. Okay? When no one else is contributing, you are less willing to do this. So these two kinds of frequency dependence has to be incorporated. Now, models. How to represent into a differential equation or whatever dynamics of this kind of situation. Now, considering utilities of that cooperative options, you see non-cooperative options. The first term is the same. Both of them decrease with y. Y is sort of a pollution level. It's a concentration, phosphorus concentration in the lake water. Okay? That is decreasing function. That means everyone likes to have a clean water. Okay? But cost is higher for cooperative option, CC. Okay? That's yes. And then non-cooperative option suffers social pressure. Social pressure is not a constant, instead that will depend on X and Y. Okay, now first factor, increasing with X. X is a fraction of cooperator among people. So therefore that indicating that conformity of the people. If many others contribute, it's a social pressure increase, you have to contribute. Okay, that's a factor. Now the next factor is increasing function of Y, pollution level. So if the people are concerned, with the polluted water, and so the social pressure increase. Now, under this, comparing these two utilities, we should describe the dynamics of how the fraction of people, cooperate will change. Okay? This is a formalism called stochastic based response dynamics. I am afraid tomorrow Professor D will speak about a very similar thing, logic dynamics, I think. Maybe wrong, so I want to talk to him before. Okay, anyway, what it says is if best response dynamics would be, this is a differential utilities, they will take the one, anytime they will take the option which has achieved higher utility. In this case, this is 0. Sorry. This is 0, and then jump into the 1. Okay? Now, this is not best response, but the stochastic best response. The fraction of people who takes the higher utility will gradually increase as a function of differential utility. Okay? So you understand. I will use this many times in my talk. Now, that will give dynamics for how the fraction of cooperator xt will change over time. You could think this is a social dynamics. Now we could couple that dynamics with the ecosystem dynamics. In this case, ecosystem dynamics is very simple. Okay, y of t is a pollution level. Okay, very simple. I see turnover. Certain fraction of water will be replaced by the influx. The influx is cooperative. Thank you very much. Okay, so that is social dynamics. This is social dynamics. Okay. Now we think about turnover dynamics, ecosystem dynamics. Very simple ecosystem dynamics. No nonlinearity. It's an influx of the phosphorus level is smaller for cooperators. X is a fraction of cooperators. Higher for non-cooperators, and then turnover time. So you could say that these two equations show the coupled dynamics of social and sort of ecosystem, ecological dynamics. Now let me explain intuitively what is happening in the system. Now people has a choice between two options. And that will be affected by economic cost and then social pressure. Now, as a result of people's choice, then fraction cooperator X of T will be determined. Now, if there are more people cooperate, then influx of the nutrients phosphorus P will be decreased. That is a negative influx. Now, whatever the process in a lake, normally lake ecosystem is much more complex. But if P is higher, then probably water pollution level Y will be larger. Then, if the water is more polluted, then social concern increase and social pressure increase. So if you look at this cycle, this is a negative feedback, right? That is only place. Now, I explained social pressure has two kinds of frequency dependence. The other kind of frequency dependence is directly dependent on fraction cooperators. If there are more cooperators, you are more likely to cooperate. So you can see that this is a positive feedback loop, right? So any dynamical system which contains a negative feedback loop and positive feedback loop will show typical nonlinear dynamics you are familiar with. And this one too. So I will explain just three results. The first one is multiple stable states. Let me think about a case in which many people cooperate. Now, you are very difficult to just get out of this cooperation. Okay? So this place is very stable and water is very clean. So the one equilibrium. The other equilibrium, no one cooperates. So in this case, you are not willing to start cooperation just because other people do not cooperate. And water is very polluted. That is also very stable state. So both of them are stable, bistable. In this particular case, there are 4 stable states. Second result is a cycle, limit cycle. Horizontal axis is the time. Okay? During this period, water pollution level Y of T is very high. Water is very polluted, so therefore people start worrying about it. So that people's concern about the environment X of T will increase. More and more people start to cooperation. Okay? When they reach a certain level, suddenly Y of T decline due to the nonlinear dynamics. Okay? And then now water becomes very clean. Water is very low. Just because water becomes clean, people lost interest. People start doing something else. Okay? So that X of T decline over time, and if they becomes very low, then suddenly water becomes eutrophic again. So this oscillation will last, perpetuate many times. And lastly, sort of unexpected parameter dependence, which I call paradox of nutrient removal. Let me see. See, just because issue is phosphorus concentration in the lake water, probably if you remove the nutrients, phosphorus from the influx more effectively, we expect water should become cleaner, obviously, right? So P of C, this is a phosphorus concentration released by the cooperators, will be, because of the improvement of the equipment, but becomes smaller and smaller. Okay? So in this case, as we expected, Y is a concentration in the lake water becomes decreased. That is exactly what we expect. But if you further decrease, then we observe sudden increase in very polluted states. Okay? And then very small P of C, we see nearly polluted water. Why this happens? It's very strange. But we can understand this by just looking at the fraction of cooperator is, if the polluted, then will be high, becomes low and really low. Because of the negative feedback, initially people are cooperative, but because of negative feedback, they lost interest in environment. They're already clean, so they are doing something else. Now, the state becomes no one cooperates. Once this happens, positive feedback will start to work. So therefore, people will not get out of this state. No one willing to cooperate, start cooperation, because other people do not cooperate. And so water stays very polluted, and that's not going to get out. So what this means is, just removing mechanically, lake water, phosphorus from lake water may not be successful. For successful ecosystem management, we must consider how people's willingness contribute to the environmental improvement is important. Okay. Now, I'd like to proceed to the second topic, which is also related to the environmental management. Now, many speakers today mentioning about this tragedy of commons. Okay? Now, this is a very common problem for open resource. Like fishermen, and they take fish as much as possible, then the resource level might decline. Okay? So this is overfishing. If they can negotiate, and then all fishermen reduce their fishing effort half of the original level, then this population of the fish might recover and everyone gains. But it is difficult because for each fisherman, ideal is all the other fishermen reduce their fishing effort, and he himself could as much as possible. See? But so therefore, this was a problem, difficulty. It's called tragedy of commons. Now, Ruth mentioned Elinor Ostrom, who received the Nobel Prize for Economics, studied this in many situations. Okay? And then she found out, of course, there are cases in tragedy of commons occur. Okay? Overfishing, overuse, and these things occur. But there are many cases also, people are successfully avoid this overexploitation. People discuss among themselves and choose the rules and punish rule breakers. These things is a sort of institutional buildings. Right, that was pointed out. Very interesting is she listed as 7 or 8, design principle. Okay, these must be satisfied for the case of successful management. You see, long enduring common pool resource management. Now, if you look at these things, many things are very intuitively obvious for me. For example, monitoring. Who is doing what must be known sufficiently accurately. That's very obvious. Also, fish levels. How much resource. According to effort. The situation must be improved. Otherwise, people lost interest in cooperation. Or if they negotiate and then someone else come and take over fish, people lost interest in cooperation. So the first one is define boundaries. Who can have a right to take fish here? It's clearly defined. Now, one thing I note, I find it very difficult to interpret initially, what is graduated sanctions. See, what is graduated sanction means? According to Elinor Ostrom, successful resource management must include sanctions or punishment level increases harm to the society. If one do something, it's rule breaking. Okay, not much. Then people go to him and say, "You are doing bad things. You should not do this." This is a little bit of that punishment. Okay, if you do really bad things, then they will charge fine. You should pay this. Okay, if you really do really bad things, harmful to everyone, then he will be expelled from the village. Okay? That kind of, punishment should increase with harm to the society. It's a graduated punishment. She said, every case, this is adopted for successful management. What is a non-graduated punishment? Harm to the society and no punishment until certain day, and it suddenly becomes very high. Okay? Now I recognize this very difficult to explain. Now you have already heard this talk from Ulf Diekman. He explained this is Ulf's work with Mayuko Nakamaru. And I don't repeat what he has done. They studies on having good scale evolution of cooperation in continuous level, together with evolution of punishment schemes and punishment intensities. I skip everything. The conclusion is strict and severe punishment is the best to foster cooperation. I think this is very understandable. Okay? If everyone invests this, if someone invests a little less, he will be severely punished. Okay? In this case, everyone cooperate. So it's very natural, but this is not what was considered as graduated punishment. So therefore, probably something is missing. So I started thinking about simplest possible model, which could explain why graduated punishment is socially efficient, very good. Okay? Very simple model. Suppose there are n players, okay? There are sort of standard, here I call pro-social behaviors. This is a sort of rule-obeying behaviors. Now there are rule-breaking behaviors, selfish behaviors. Oh, let's think about illegal parking. Okay? If you park the car where you should not, and then just finish your work and go, then you can save your time. No, of course. And that is a benefit, personal benefit. Selfish person will gain. That's a B. Okay? Now, illegal parking might cause a trouble to other people. Okay? That's the total amount of harm here, H. Right? To stop this kind of illegal parking, we should charge a fine. Punishment level. Punishment level is P. So we like to find out what is the optimal P. Okay? Now, fraction of or number of players who takes the selfish option instead of rule breakers instead of the pro-social option is N of S. Now, what is the number of people who takes S option? I already explained this. This is exactly the same as before. Okay? We think about utilities or pro-social and selfish options. Okay? In this case, first two terms are the same. Basic level minus harm. Harm, we assume, is equally shared among all players. Very simple. Okay? Everyone suffers. Okay? Now, in addition, selfish option, selfish player gains personal benefit B and suffer has to pay punishment. Okay? Now, what is a fraction of players who takes selfish? This is exactly the same as before, I explained. Slightly different terminology, contal response interview. And probably tomorrow, logic to contal something, There are many jargons in social science, doesn't matter. Same thing, Best response, go 100%, but in the stochastic response, best response, there will be increasing function as differential utility. Then we have to assume what is a criteria to judge the desirability of particular social institution over the others. Okay? I would take simplest possible case, which is a total sum of utilities of all members in society. This is sometimes called social welfare function in economics. Now, very simple. Now, if you look at this one, P appears as negative, so you thought that this is always decreasing this P. It's not true. NOS is fraction of people who take selfish option will decrease as the punishment increase. So therefore, there can be optimal intermediate value of P. Now I will skip all the analysis. Now, one thing I note is, if there is no mistake, we often see that infinitely strong punishment is optimal. What this means? Suppose, parking violation, punishment to parking violation. Now, illegal parking benefit this one. Harm is smaller than this. We should allow him to do illegal parking from the social viewpoint. Okay. Now, harm is larger than this benefit he received. We should stop him doing this. To do it, we should put very strong punishment, like death penalty for parking violations. Okay? If the death penalty parking violations, no one will park, of course, illegally. Okay? So the society becomes a very nice place. I don't think that's true, People feel uneasy. So therefore, something's wrong here. Some missing element. This logic is very clear. So therefore, we thought about to prevent this infinitely strong punishment to be the optimal. And I found out two things important. One is mistake. Mistake in evaluation. Some person doing, obeying the rules, but by mistake he is identified as rule breaker and being punished. This is epsilon 1. This is a false accusation. You see, false accusation. He didn't do any bad things, but by mistake he's regarded as criminal. So epsilon 1. Please remember, this is very dangerous. Okay. Now opposite is true. Someone did selfish action people did not recognize. That is an epsilon 2. This is less important. Now, if you incorporating this possibility of mistaken evaluation, you can calculate optimal punishment level. Fortunately, this is finite. You see, horizontal axis is harm to the society, and initially 0 and then jump. But this, unfortunately, increase very slowly. Very slowly. The dependence on the amount of harm is a logarithmic dependence. Very slow. So I think this is not what Elena Osler mentioned about gradual punishment. So what is the element missing? Punishment which increase like this should be somehow good. Then I thought about heterogeneity of players. Beta is a sensitivity factor. See, if certain people has a very large beta, that means he will be close to the best response. If the certain option is slightly better, then he will 100% take that one. Slightly lower, takes the other one. Okay, switching like this. But other people are more stubborn. He knows he will be punished and he will lose, but yet can't stop it. And some other people are really stubborn. He will not never change. So suppose population includes those kind of people has a different value, different sensitivity to the utility difference. Then what happens? Okay. Specifically, I assume in this particular case, I assume beta has a distribution, exponential distribution. That means large variance. Some people have small beta, some people have large beta. You can see that heterogeneous population. See, I think that is quite well described as a sort of gradated punishment. Now, instead of distribution beta, you could think about a population in which everyone beta is exactly the same. It's a homogeneous population which has the same mean value of beta. Okay? So I think that is a conclusion. I even derived optimal punishment is proportional to the amount of harm that will cause, square root of harm, and inversely proportional to probability of false accusation. So that's the conclusion of the second part. Graduated punishment, it was identified by Elena Ostrom as the most important element for successful management, resource management, is socially efficient if there is a chance of false accusation and people are heterogeneous in sensitivity to defense. Combining two parts, my message is very simple. Many environmental problems include social dilemma, and that can be solved by people's pro-social tendency. Obviously, this has been evolved by direct responsibility or by institution. Thank you very much.
Thank you for a wonderful talk and very clear and I would say appealing conclusion. So, time for some questions, please. Will you ask a question?
So, Professor Iwasa, I'm very interested in the logic response dynamics. In fact, it's part of my PhD thesis. I study the control response equilibrium. So, as far as I know, you have a parameter beta with the sensitive factor. So, this is very crucial for the control response dynamics, as far as I know. So, if you change the beta, the number of equilibrium will change, and also the dynamic structure. So, have you seen this in your model? For instance, sometimes we see chaos.
Yeah. I didn't analyze much about dependence beta clearly, but I think that I have to know that although I often use replicator dynamics myself with other collaborators, but social scientists often use this best response instead of the replicator dynamics. If you look at the Kandori or any others, they all assume not replicator dynamics, but best response time. So I think it's they have the empirical evidence to support this one too. So I feel more comfortable whenever we discuss the forest deforestations, exploitation, all these things. I tend to use this one. Yeah.
From your presentation, I thought you calculate the logic equilibrium, isn't it? The equilibrium of your equation. So the number of equilibrium, also the position of that equilibrium may change with beta.
Yeah, I agree. Yeah.
Okay,
Thank you.
Other questions to Yoh? Yeah, please, that's me.
Thank you very much for your nice presentation. I'm interested in effects of counter punishment because if the amount of penalty is so weak, which may invite the temptation of counter punishment. Problem is how to authorize such institutional punishment. Sometimes really such death penalty punishment can support authorization of institution. It's a kind of chicken or egg discussion. So could you provide any comments on my talk?
No, I agree that's important in certain cases, but our attempt is just focus the first step on answering what is the element, and we can incorporate the cost of the punishment itself or this counter punishment too into this kind of schemes. But I want to examine that.
Thank you very much for an interesting talk. I was particularly intrigued by your incorporation of social pressure in ecosystems management. And I was wondering if you could comment on the role of misinformation, because I think there's an additional aspect to the problem of ecosystems management, and that comes from companies. And so they may have an interest in kind of misinforming what the causes are for the stinking lake or something like that. And then there's a sort of potentially a hypocritical component of the players involved, in the sense that they might be stakeholders in companies that produce fertilizers, and at the same time they have an interest in having a clean clean water. So is there a way to incorporate aspects of maybe adding companies as additional players to your model?
Yeah, I think it's one thing we can treat that as uncertainty for certain information is not really accurate, but we don't know whether what company says or this scholar says is correct. But also, the strategic disposition of the information is very often the case. People, I don't have that many efforts, but this kind of reputation, like Mayuko, long time ago, this the paper, she's thinking about distributing the information that she is a nice person or something, But so if evaluation coming in, then there's always the case that the people tell a lie and try to improve the situation. So I don't know. I've not worked on this, but it's a very important element in thinking about this.
Yeah, I also wanted to take the time to reflect a little bit on the distinction between these abrupt onsets of punishment and the gradual punishment. I fully agree that in reality we often find the emergence naturally of the graduated punishment, and I think for all of us it feels often a bit wrong to have these kind of abrupt thresholds. Our sense of fairness is violated by that. And I wanted to highlight that your perspective for deriving your graded punishment was a social planner perspective. You maximize the societal welfare, the social welfare, and that gave the graduated response. What we did was individual level evolution, where the emerging punishment reaction norm came from the selfish interest of the players. So these are two very different perspectives, and like in so many other areas of cooperation research, bridging them is a challenge. Now, secondly, we already have heard about some social complexities that probably also promote graduated punishment, and I would like to add two facets to that. First, and that's probably easy to add in your model, there's always a cost to the punisher. It can be just the act of punishing, it can be the social implications that actually if you look at punishers in groups, they are often not liked people. They are kind of admired maybe for their courage, but they are not liked. So they lose some social capital by being so courageous and upholding the social law, but it's not necessarily an enviable position to be a well-known punisher in a society. So that's a cost. And then a third cost is retribution by the punishee, by the person who is attacked, who might just sneak back at you and hit you over the head at another moment. So that is the third cost. And then I also would like to highlight that graded punishment may be promoted by what Christopher has presented. People get frustrated. If they get punished, they get frustrated, they might even contribute less next time because they lose their spirit. And maybe having lost their reputation, there's no purpose in punishing, in cooperating anymore. So I think we could potentially add these three costs of punishment and also these antisocial aspects of punishment into a model, and probably it would give an even more graduated punishment response. What do you think?
Yeah, maybe. But the second part is not the peer punishment, it's poor punishment. So probably some society will decide rules, even if they are not liked, maybe they hire the policeman and punish. So yeah. All of them you mentioned is important.
Just one technical question.
Yeah.
In one of your utility function, you had this decreasing returns. I think it was a blue curve back.
Which one? It's a
no, further back. Sorry. Oops. I think you lost it.
This one.
No, it's a picture where you have a decreasing returns curve, where you show that as a function of the harm to the society.
Okay.
And Is there any special reason for the that's the one for this curve to be in decreasing returns?
Which count? Sorry.
Oh, you just passed it. It's this blank line that is no. One more back.
I don't understand. Sorry.
Yes.
Maybe we should discuss.
Just continue.
No? This is the end.
No. Oh, so you were going for. Well, I can ask you later.
Yeah. Thank you. Thank you for your answer.
Sorry.
Yeah.
All right, because Yoh was so efficient with his time, we do have time for another question if anybody wants. Yeah, Hisashi, please.
Thank you very much for your talk. And in your second part, you mentioned heterogeneity and the sensitivity is important. But what if other parameters are heterogeneous? For example, maybe the benefit of benefit of parking can depend on people. So in that case, B can be also heterogeneous. Or I can imagine other many cases. But what if other parameters are heterogeneous rather than beta?
I have not examined every possible cases, but I should. But if people are maybe B is different. Okay. Thank you.
All right, then let's thank Yoh once more for his talk. Thank you very much.